But we're ready to talk soil, yeah?
Yeah.
As far as soil and soil systems, it's a lifelong study. Getting to know soil, different places. Every time you dig a hole, you're going to discover something new. But in terms of resources and what's printed out there in the English language, the Gaia's Garden is very contemporary and I think a great overview. Some of the foundations of that work, I would suggest potential reading, would be a book called An Agricultural Testament. It's by Sir Albert Howard. The guy got knighted for this kind of work. He went to India. He was British. What are we talking? 1940s, 1930s odd, and studied their agricultural system and how they were building soil with organic material, with manure, composting, and wrote a book and really helped turn around some of the agriculture that was going on in the British Isles. Turn these folks into the second stage of their gardening renaissance. Sir Albert Howard. Sir Albert Howard. And then there's another book that I would strongly recommend that Steve can probably find what the name of the author is online. But it's called The Farmers of 40 Centuries.
Oh.
It's a really...
No. Sorry. Key? No?
Could be Key.
We'll find it.
I couldn't find the title in the library, but it is a wonderful book, and I think it is another foundational piece of this discussion. It really goes into how agriculture has persisted in Southeast Asia, and this guy went over and toured, at the turn of the century, and looked at all the different agricultural techniques that were going along, that these people had been at the same spot, dense populations, 4,000 years, and able to continue to grow rich and nutritious organic vegetables.
The author is King, 1911.
1911, this information. So over 100 years ago. Probably went over in a steamship or something.
He did. He died on the way back too, in his life published book.
Really?
Yeah.
Smart lady.
Yeah, he was over there for like 5-6 months.
Fascinating.
Fascinating book. He's on a train and all through China and Korea. Great book.
Yeah.
It's a great read. It would be an epic re-journey through that area. Really
You should do it.
Okay, we'll put it on the list. What else we have in front of us? I love this book, Edifice. This is published by a local guy, Paul Sachs. He owns North Country Organics, which is a really great resource for soil amendments and so forth. He's more into turf these days, but this is a great foundational book, just to nuts and bolts science right here. This is a little bit more conventional resource that gets into more of the chemistry of stuff, the nature and property of soils. We'll get in more composting and outdoors and so forth, and in the field. But this gives you an idea how much information is out there just on composting. This is a Rodale publication, and thick. This has a profile of, say, all these different organic materials. It's just immense, and it includes like obscure things like insulation and roofing tiles, and like things you probably wouldn't consider. But it lists their benefits and possible negatives as well. So it's just an immense body of knowledge right there.
What is it called?
The Complete Book of Composting.
It is complete.
It is thorough. And then I guess that's an aspect of it. And then this is a really interesting aspect of it as well. This comes from along the lines of these authors published another book called The Secret Life of Plants, and so then they wrote this book called The Secrets of Soil, and it really goes into more of the energetics and life forces that it almost crosses the boundary into like intelligence, and looking at soil as a living system, and just how it reacts to stimulus, how it reacts to... The Secret Life of Plants talks so much about how if you talk good to plants, they respond, and similar stuff in this book. So it really goes into more the almost metaphysical aspects of the soil. So
They have the documentary for the Secret Life of Plants on Netflix right now, I think.
Oh, cool.
It's got a Stevie Wonder song in there. Secret Life of Plants. Anyway.
well,
I love this group.
yeah, add to the discussion. So dirt, they also have a movie on dirt. They're into movies. Another just way to look at soil and just as this living system, just as how important it is, and how complex it is, and how much we need to value it.
Josh, would you pass those around?
Sure. I'll start these this direction,
Yeah.
start those that direction. And then we'll turn up the Farmers of 40 Centuries and Sir Albert Howard's books as well over the weekend. I just couldn't find them when I was searching around. Alright, so in terms of my talk, I think we really just need to emphasize that soil is a living system. There's a figure that circulated around in terms of what's in a tablespoon of healthy soil. Talking millions of microbes, like on the level of how many people there are in New York City. There's microorganisms living in that, so there's a tremendous microscopic world going on. And so you got a New York City in your tablespoon there. There's a lot of activity going, right? New York City is a busy place, and so all these different critters, in this microscopic world are interacting. They're eating, they're pooping, they're peeing. They're like worms on a microscopic level. You know how important worms are? To just go pile through stuff, and what comes out is something else eats it, or something comes along and eats that. I mean, it's the microscopic world that's down there is like this outer space alien adventure that we just can barely imagine. You're talking arthropods, and it's just there's a lot of things, but if you look through the microscope, you would be very glad that those things aren't as big as us and running around. They're scary. Pinchers, and there's a lot of predator-prey relationships happening in that ecosystem. It's a busy, active place. Those things are eating one another and fighting, and it's a busy place. In terms of your soil in general, you're looking at distinct components. Basically, your constituent parts are your clay, your sand, your silt, and your organic material. And silt and organic material somewhat overlap. But that's sort of it. That's all you got to juggle. So different soil types are going to be 30% sand, 40% clay, 30% silt, or a variation on that. It's, majority speaking, mostly sand and mostly clay. Your silt and your organic material will tend to be less in that percentage.
Josh, forgive my naivete, but what exactly is silt?
Silt is very similar to organic material, but silt is something like, it's slippery like clay, and they're fine particles that have floated to that location.
Okay.
Clay is something that's more metamorphic in process, how it was created, and sand is more of an aggregate. So it's more of individual granules of mineral composition, silicon most of it. Am I on the right track here?
No, you're on the right track. Yeah.
Oh, that's right. We have an expert in the room, so if I go off track, he's going to tell me on it. But anyway, in regards to that composition and learning your soil, it's important to recognize those constituents. So what you're working with. Is this a clay-rich soil? Is this a sand-rich soil? And then you're going to react. It's going to have a different drainage capacity. It's going to have a different nutrient capacity. It's going to do different things when you walk upon it. It's going to do different things in mud season. Getting to know your soil based on that composition is important.
If I may add to that, when you talk to an engineer, that's as far as they go with soil.
That's
really all. When you talk to an engineer and they've taken a soils course, what they've taken is a structural soils course, and they look at the interaction between sand, silt, and clay, and what kind of low-bearing surface you can have on it, and that kind of thing. But beyond that, it's one of the things that I deal with on a large basis with what I do. They don't look beyond that. So it's a real educational process trying to get them to change. That's all they want to look at and decide what's a good soil and what's not a good soil.
Yeah, the engineering perspective is definitely a structural assessment, and the farming perspective is more of a living systems development. Okay, so how are we going to build soil is the fundamental question. And what we're a proponent of and an advocate of is building from the top down. Okay, that's fundamental when we're looking at the soil system. When you think of the alternatives, and the conventional alternatives is using a plow, which only goes so deep, is very energy intensive, and it is disrupting a natural system. So, just in terms of developing this perspective on what would be a natural system, we could look to the prairies, say, of the United States is a great example. When the settlers got here, there was an established ecosystem of the prairies. There was large herds of animals running through, and there was millennium of soil building. And then when they arrived here, they had up to 6 feet of soil, yeah?
Wow.
Just topsoil. It's just, there's a rich, the history of this landscape is just tremendous. You know, people went in there and just sunk the plow to it, and there was bounty and abundance. That was created over time. I have the ground here. You have more or less the grass grows up, yeah? Bloop, 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 bloop. And, you know, you got grazing animals coming through, and they eat the tops here and there, and they do a little, this business, you know about this business. And then winter comes, and it snows and everything, and all this stuff gets beat down, ends up debris on the ground. And then next year, spring is here, everybody grows right back up, and then the horned critters come along, and they eat, and they do the little poop again, and move along, and winter comes, and then everything falls down here. This is not very complex, though, but over the course of thousands and thousands of years, this is how they build up the soil. There's,
Could I add to that, Josh?
go ahead.
It's just, I don't know if it was in Dirt, the movie, how they talk about the root system being actually this incredibly hidden part of that whole cycle and I never realized that when the herbivores are eating grass, that it's this, the roots proportionally die, and that's where a lot of the soil, and I never even thought of that.
I think that is dirt. They like hold it up. They cut down into like a prairie, and you look at the cross section.
This is definitely a very integral part of this system because these roots also are bringing up the moisture and bringing up the nutrients that are unavailable otherwise. There's no way for us to dig down 6-8 feet and pull up the calcium, the magnesium, all the trace elements that we need in this topsoil and this nutrient level. Nutrient rich and biologically rich level. And the reason that this level is so rich is it's one of these boundaries, one of these edges that we keep finding in the margins in our ecosystems that are so plentiful. The estuaries, these boundaries between different types of ecosystems produce more diversity. And so on the whole surface of the earth, we have one of these boundaries. And it's the boundary between earth and sky. And it's about, depending on how much air can get down there, 5 to 10 centimeters thick. So you're talking 2 to 5 inches. Somewhere in there, that first 2 to 5 inch layer is where air can penetrate, moisture can penetrate, and different activities can come up. You know, the nutrients that are in the core of the earth can make their way to this boundary. There's just not a whole lot of life 3 feet down. roots are penetrating and so forth. But if you're talking about active biology, it's just not happening down there. You dug a hole recently. There's a big difference between the first 6 inches and deeper.
Yeah, and also a big difference depending on where you dig the hole.
Okay, so where the soil is richer, it's been built up. Where that brown layer, where that organic layer is, it wasn't manifested from the bottom. It was manifested from the top down. And so our argument to a degree is that the plow is degrading and destroying that natural system and is really a short-term fix. And the prairies now, the actual depth of these landscapes that were up to 6 feet deep are now down to like 6-8 inches in some spots. And it's through this plow process where you're ripping up the layers and exposing it to wind and rain and erosion. And so that's where keeping coverage on the top of the soil is very important, keeping a mulch layer for moisture retention and for building the soil from the top down. That mulch and that moisture helps create a better environment for the microorganism. It shades them from the heat of the UV rays and so forth that destroy the microorganisms, and provide that moisture and material is actually fuel for all this process of life. In terms of building the soil, I guess what we're looking at is a couple different methodologies. There's the composting and mulching, which is more or less incorporating more material into it. Yeah. And then there's cover crops and green manures. And there's slightly different variations in terminology, but they more or less go towards seeding in specific crops that of your designation. You got to buy the seed or procure the seed, and you're picking specific crops for the benefits that they could incur onto that piece of land. So you have to choose, and there's a lot of choices out there. So you can choose annuals, you can choose perennials. These choices are based on what's going to seed in well for that time of year. Is it earlier in the year? Is clover going to work better than, say, buckwheat in the heat of the summer? So there's some choices there in species. And there's also choices in terms of how your seed bed's prepared. What's going to take on that seed bed? Is it a very rough site that all that's going to grow that first time out is some very, more or less what they use for erosion control on roads? Or is it soil that's more friable and more fertile, and you're able to seed in something that's more delicate, say like buckwheat, once again. But in, what's a typical erosion control mix? Rye?
Yeah, I usually, we still work with a lot of annual ryes, although I'm not a big fan. Perennial rye, some type of fescue. I like a tall fescue. Generally try and go with 2 different kinds of clover, the white clover and the red clover.
What's fescue?
Excuse me?
What is fescue?
Fescue is just another type of grass. It's a clump grass. Ryes and fescues are clump grasses. A lot of the old specs you used to see a lot of bluegrass in. I have no idea why they put bluegrass in.
I think it was aesthetic. People.
It's
sales pitch.
Came out of the 30s and 40s when that was the grass that we all wanted to grow. So, and I think from an erosion control standpoint, they looked at it as it's a spreading grass as opposed to your clump grasses. So they were looking to get better cover. But I think eventually most of those sites will go over to clovers, because most of the time we're talking about extremely poor, nutrient levels in the soils if you've got any structure at all to the soil.
So let's start there. Let's start about talking about some extremely degraded soils, like say after a construction site, you've had a lot of turbulence there, and the subsoil's been all mixed in. It looks really sandy. There's lots of rocks. What do you see there? You go probably with this erosion control like mix, and then think about mulching or sheet mulching over that. After you've got some control over erosion, you get some initial growth. Because you just can't go into one of those sites and start planting your basil and your tomato.
No.
It's either going to take truckloads of compost or a slow, gradual process where you're getting some vegetation in there that starts building the soil from the bottom to the top. The soil looks like more or less like the moon, or like you imagine Mars. It's virtually lifeless. And so what we're looking to do is inoculate this web of life as rapidly as we can. And the web of life, besides all these little critters and so forth, there's also more similar to plants, more like mycelium and mycorrhiza that is literally the web of life. The mycorrhiza is what helps translocate all these nutrients, particularly horizontally and vertically. These moisture and nutrients has to find a way to travel. And the mycorrhiza serves as this transportation network. It's very fundamental. Whereas if you can imagine, once again, you've taken that tractor or some sort of implement to it, just like a very mechanized, powerful tool, it's just going to rip that existing system to shreds. When it does that, it's going to give you a big burst of energy, right? Because it just wreaked havoc on, it was more or less did a catastrophe. It was like a typhoon or a tsunami or something. And what happens is everybody goes out and starts looting. Literally, there's a frenzy of bacteria and microbiological activity because there's been a lot of air introduced to this environment, and there's been a lot of destruction, savage destruction. So they're just literally trying to pick up the pieces, and they go back to work and try to rebuild their civilization. And it creates a flourish for the plants as well. All that activity, all them moving and killing one another and doing their thing creates activity for the nutrients for the plants to uptake. So the plowing is very successful often in the first, second, third year. It creates some weed problems, but as far as your fertility of your plants during that initial phase, it can be very high. But if you keep looting and you keep creating catastrophes, then eventually your system breaks down. You can't endure that sort of cataclysmic events over time if you want to have life.
Yeah, you get diminishing returns.
And you turn the place more into the moon again. So this is what the tractor is doing. People are running mechanization over their fields 6-10 times a year. It is beating the life out of the soil, compacting it, turning it up, compacting it again, turning it up, compacting it again. And this is nothing like what has been done on this scale on this planet. This is new. This is the last 150 years. On the scale that we're doing it, it's just tremendous. And so we're literally destroying our life. How we can perpetuate. In terms of another component of the building soil, we talked a little bit about composting and mulching, and a little bit about cover cropping and green manure, but there's also soil amendments. The fellow Paul Sachs is a distributor of different blends and different specific amendments. It could be a somewhat overwhelming list of stuff that he supplies, stuff that you might not have heard of. Green sand, black rock phosphate, azomite. It's just where's this stuff come from? A lot of it is mined. Azomite comes from a big pit in Utah. People love this stuff. It's somewhat controversial. Green sand provides a lot of trace minerals. It's very slow release. It helps build your soil. Yes. Does it come from industrial, conventional, fossil fuel driven? Yeah. Another route within that is sort of in the amendment genre is different formulations. Right? And Michael Phillips will talk a lot more about this, but you got like compost teas, you got liquid algae, different formulations that you're actually either spraying on compost pile or directly on your soil or directly on your plants. Effective microorganisms. And there's all kinds of recipes for brewing up distinct stuff. And I think within that, it's important to consider the longest running school of agriculture, the biodynamic, is a very the advocates of biodynamic are very serious about their soil preparations as well. They can be a little bit obscure and esoteric as well. Different mixtures, and making these concoctions and then putting these soil preparations onto the soil and onto the plant material. So it's important to just sort of be aware that school of thought exists. I'm no expert on that, so I can't really speak to it.
Josh, do you use much any wood ash?
Wood ash is a controversial ingredient for us in terms of compost and putting directly onto soil. I've heard different things, through the years. Some people are pretty much proponents of it, and some people are just gun shy. Mm-hmm. What I'd heard is the science of it a little bit is very strong, very alkaline. So potentially, if you have very acidic soil, it could help mitigate that. But it seems like potentially it is more of a quick fix that doesn't really potentially have long-term effects at sweetening the soil. That being said, it's also very caustic, just in terms of material. And so there's, I think, some concern about how much to apply and in what situations to apply. It is available and abundant. I would, from my frame of reference, I'm just cautious with the stuff.
Mm-hmm. It is pretty much like that in a gold medic lime, or
very similar to a lime, and very caustic as well, similar to a lime. A lime can, if you're a microorganism or if you're a worm and you get some lime on you, it might not be a good experience. It'll burn you. So it's just how to incorporate that into your soil system, and for the cost, for how to incorporate it, in terms of energy and efficiency, and then for the long-term benefits that you're going to derive. It's an important consideration with all these sort of strategies, be it the compost and mulching, be it the cover cropping, green manure, or be it the soil amendments and effective microbe spraying and so forth. What we're getting at is really figuring out the percentages of what you'd like to have and how to get to that level. And the real percentages, once again, we started with the sand, the silt, the clay, and the organic material. So organic material, you can go high, and it's going to help you. But what in terms of your resources, what are you going to be able to attain? If you can get up to 6-8%, that's considered pretty darn good. That doesn't seem like a lot, but it's considerable when you think about field agriculture and so forth. 6-8% is pretty darn high. Yeah, even straight up compost has got almost 50% probably mineral material to it. So to get to 6-8% on acreage is that's where you want it. Yeah, I mean, there's people that will analyze it visually and do taste tests, but I think taste tests. I've seen some of the taste testing done, but the determination, I think, a lot of the time is based on performance, and a lot's can be determined by the weed presence.
Yeah, the plants around.
Plant indicators, indicator species. So if you have a lot of fertility, you might see lamb's quarter pop up everywhere. We have there's a lot of lamb's quarter in our greenhouses and so forth because we keep compost in there. So that's an indicator that you have fertility and nitrogen in your soil. Whereas, cheese and crow, what's a
good company, Jennifer's company, and they did a complete write-up on the property where we want to build and start working off of. They did soil sampling and water sampling.
Doing some chemistry experiments and also growing some things out. So there's sort of a biological type element to it. We just had a test sent off to UNH, and it's sort of a standard test, $20, and they give you back some suggestions and so forth through the UNH extension. And then Cornell goes and does something way more extensive that could cost you up to $100.
So even you send away for soil testing, even having this much space and knowledge, you still...
He does a taste test.
Yeah, you like to compare, you like to keep update, and lots of our funding, like NRCS type funding, is linked to those sort of evaluations and so forth, so they're coming out and sort of forcing it on us.
So here's like another, for a small scale site, we've never sent anything off for soil testing. We've done some of our own just out of curiosity, but one of the permaculture perspectives to soil testing is that it's very much like a reductionist view, and it's out of context sometimes. So even if you get data back and it says you're low in calcium or you're low in something, we're tending to look at a very long horizon of change. And like through adding plant material, cover cropping, composting, we're looking at changing, building the soil over a much longer time horizon that the data I might get back from the lab might not be as useful to me. And it's out of context with what's there, whereas the indicator species are going to tell me, am I low on silica, am I low on this, or what's going on. And in the visual inspection and the watching it over the season and seeing how it retains moisture, that to me that's a lot more useful, but that takes the observation and analysis component and the interplay of that we'll go to after break of landform and water, and what the roles are in the presence or absence of water, and like all that paints a much more full profile that, like Josh's time here on the property, I think all that value can't be replicated in the lab.
And it's just like the digestive system, so it's like, even if you have a blood test and it says you're low in this and high in that and low in that, even if you went to the pharmacy and got the supplement, probably not assimilatable, or, the quality of the supplement.
I don't think we can negate the value of the chemistry experiment and the scientific lab work. It's definitely important to establish the parameters, but it is a snapshot oftentimes, rather than the soil is constantly evolving. So in that snapshot, it may show we've augmented the organic material on a certain plot, and we got it up to 10-12%. But the snapshot's not going to really show that battery bank in what exists there in terms of the nitrogen, potassium, phosphorus, trace minerals that are all tied up. If you put that through a solution, you're not going to be able to access the abundance that is in that system. And so for organic farmers, for us, it's sort of looking at it over the period of time. So it's important to get that baseline with your tests so you can work towards your goal. In terms of basic The terminology. Plants need, say, 50 odd, maybe 60, up to 60 of what's on the periodic chart. You know, when you look at that periodic chart, plants need like 60 of those elements. So we had to come up with that whole medicine chest right there. The very prominent ones are the NPK. When you talk about the 10-20-10, got your nitrogen, potassium, nitrogen, phosphorus, and potassium. The K is potassium. And those are percentages. You know, they're just trying to throw numbers out at you. But those NPK are often sort of overrated in terms of their importance. They are very important, but you have to also include those other 60 elements. And then the pH, you know, you have a pH scale, I think it's 0 to 14. It goes up, each scale is like 100 times more, so it's elusive in terms of scale, but it's really exponential in terms of its caustic. And so right in the middle is 7, that's more or less neutral. If you get your soil between 6 and 7 in New Hampshire, you're doing pretty good. It could be down as low as 4.
Yeah, you get an oak or a pine forest, and it's typically in the 4 to 5 range. And then we try and grow grass on it.
So it's very acidic.
Set yourself up for failure, right?
Pretty much.
Yeah.
And so I guess alkaline soils are more maybe limestone based, that sort of thing, and you have the reverse problem. In terms of remediation and so forth, we have, you know, our situation here where it's very sandy, so we're constantly adding organic material. So I think we should briefly discuss what you do with materials, soil that's too clay. I think if it's too clay, you have a difficult time accessing the subsoil and so forth. You have to find ways to help penetrate the soil. You can use either deep-rooted plants or add other nutrients, perhaps, or amendments, potentially mulch, organic material, or in extreme cases, maybe even some sand or loamy material. Because the clay can just be...
this whole idea that, you know, the small sticks that trees kind of slough off, they're trying to do that to feed the root systems that Josh was talking about and all those mycorrhizae that are in the soil, and they're returning calcium and all these elements back to the soil. And we have a tendency to go out ourselves or hire a landscape company to cut those sticks and cart them away. So Michael talks about it in a holistic orcharding perspective. You're out pruning and you're doing some of these things, you know, returning those things to the soils are critical. What you got?
Cycle.
So, yeah, in terms of this tree of life, you know, the tree has figured this out. It's going to feed itself. You know, it's sort of developed this pattern. But when you look at the energetic potential of the remeal wood, it's commonly, you know, less than, say, 3 to 4 inches in diameter is what we're referring to. And it's chipping it up. And the reason it has so much more energetic potential is being more, the diameter of it is less than a big tree. So in a smaller tree, more of this cambium and bark per volume to this pith and hardwood. When you have this pith and hard sapwood right there, and then you just have less per volume when you're chipping. So the percentage is closer to, you know, say 50-50. It really helps in decomposition. It really helps with the quantities of nutrients that are available in that particular volume if you're volumetrically. But yeah, remeal wood is really important. There's a whole, I mean, that complete book of composting really is in depth in terms of all the possible cover crops as well as ingredients that you can use that are out there in terms of organic material, derived from materials, mineral materials that can be used to create soil, enrich soil.
So when we sheet mulch, it's just general soil building, but you don't know what you're going to get.
When you sheet mulch, I mean, the purpose of sheet mulching is multifold. You're looking to suppress potentially what's there. So if you have something that's coming up vigorously, you want something else to have more space. And as well, it covers everything, so there's shade now there. And moisture is being better retained in that level. And then as it degrades, like the worms really dig the glue in the compost. It's got a lot of protein. So they just like turn it into tilth. And so it's a patient process. It's accomplishing multiple goals.
So it's more preparing the soil, but the nutrients in the soil, are they going to be basically the same, or is it going to be based on what was there before, the type of vegetation that was there before?
The nutrient
You see what I'm asking?
Yeah. I think the nutrient load is primarily going to be carbon. You know, it's more like paper of the cardboard itself. But then we're going to heap some other stuff on top of that. And we're also going to empower the system by like raising the moisture and by protecting it from the sun. Like we've just energized something. We just plugged it in.
Right.
So that whole, getting that system up and running, starting, is half the battle.
Plus, what about the decomposition of whatever you covered?
Right.
Yeah, absolutely. All that's going to go right into the system.
And then,
So it is. It's just building upon the system, incorporating more material, doing layers, lasagna garden.
and it's only one of the strategies we're employing, because then we're using dynamic accumulators with those deep tap roots that we looked at, that are then going to bring some of the unavailable minerals from the subsoil up and make them available to plants. So we're using multiple different strategies, not just sheet mulching, to start to really build that soil, make it
I
available.
think that's very important. The sheet mulching is one aspect of a soil building strategy. You know, you're using the different plant components as well. You're doing your different composted, your different ingredients, your different strategies.
But from the readings, well, from last time we met, you talked about sheet mulching in the first year, and coming back and doing it again the next year. So you're really taking time to develop that soil.
Yeah.
Yeah. In some situations, it may take more than 1 year. In some situations, you'll be able to suppress what you need and start with a volume.
Okay.
Chris?
I've been, this month I've been laying a lot of black plastic on a farm, and the sheet mulching concept seems like it could almost completely replace it if we got the system. Like, it might take a year or two to get the cycle going, but that combined with like perennial like ground covers, I feel like it's like huge potential to, because like, you know, black plastic, it protects, it does all the things of sheet mulching, but you know, it's plastic and it's looks funny.
It doesn't allow the soil to breathe.
Mm-hmm.
And it doesn't allow the natural rain to percolate down through the system. So you get hot and cold spots underneath there where the drip goes down through. You know, you might get some moisture, but there's dead zones underneath there. It's
Yeah,
like
she's
a
already
cornfield.
mentioned the dead zones of like that corner, no matter what, it just doesn't grow. It's been under plastic for 3 years, so yeah. So it's just been really interesting, like doing it that way, the more traditional organic way, and then kind of learning this different approach to do the same thing.
Well, once again, it's a question of time management, cost control. The black plastic is extremely effective.
It's fast. Yeah.
Fast, quick, easy on your labor. Cost-wise, you don't have to. I mean, it takes a while to accumulate that kind of cardboard.
Yeah.
And so, you know, that black plastic comes in a roll, it gets delivered. There's a machine that rolls it out, flips the soil over the side. You want to feed a lot of people. You either need more people or more black plastics. I guess I just can't overemphasize how much there is to learn, how complex the system is, and how important it is. It is just really, it's the web of life is down there. And that's what makes all these things that we cherish, these microorganisms. 9 million of them in a teaspoon or a tablespoon.